Welcome back to another video. This is the last video of my trigonometry series, and in this video it is a continuation of the trigonometric equations part 1. We're just going to look at more trigonometric equations and solving them, and specifically we're going to look at trigonometric equations that have multiple or has more than one x or some double angle or triple angle, and so we'll look at how to solve those, okay? And I'll show you exactly what I'm talking about. So let's look at some examples. We're going to jump right in. This first example, we want to solve cosine of 2x equal to negative 1/2 over the interval from 0 to 2 pi. And so this is what I mean by having multiple angles. So before, every equation that we solved in the last video had only an x within the argument. Well, this time we're going to have more than just an x. We'll have like a 2x, a 3x, or 4x. And so we're going to look at how to solve these types of problems, okay? Well, first of all, this one is, if it has a 2x in it, then you can use your double angle identities. And so in this case, we could use the double angle identity for cosine. And if you remember, there were 3 different double angle identities for cosine. There was one that had only cosine in it, and there were 2 that had both sine and cosine in it. And so we will want to use the one with only cosine in it, because remember, you only can have one trigonometric function within the equation in order to solve for it. So if you remember, cosine of 2x is equal to 2 cosine squared x, so square 2 cosine squared x minus 1. Okay, so what I did was I replaced cosine of 2x with this 2 cosine squared x minus 1, and that's by the double angle identity. Okay, so I'm just going to make a little note here. That's by the double angle identity, which I'm using DAI to represent, so I don't have to write all of that out on my screen. Okay, so now, since I only have cosine of x in the equation, I can isolate cosine of x. So I'm going to add 1 to both sides. When I say only cosine of x, meaning that's the only trigonometric function in the equation. So when I add 1, I get 2 cosine squared x equal negative 1/2 plus 1 is 1/2. Then I'll divide by 2. And remember, when you divide by fractions, you do the keep, change, flip. So that'll be 1/2 times 1/2, which is equal to 1/4. And so then I'm going to rewrite that cosine squared x equal 1/4. And to get rid of the square, I will take the square roots. And I would need to take the positive and negative square root. Anytime you take the square root, you take the positive and negative square root. The square and the square root cancel over here and leave me with just cosine of x. And the square root of 1 is 1. The square root of 4 is 2. So you would take the square root of the bottom and the top. So that gives me cosine of x is equal to positive and negative 1/2. So now I have to look and see. And so we're going through just one rotation. So I have to look and see everywhere where the cosine of x is positive 1/2 and negative 1/2. That means I'm going to have 4 different answers, because it's positive 1/2 in 2 quadrants and it's negative 1/2 in 2 quadrants. Okay. So if I think about that, cosine of x, if I look at my unit circle, cosine of x is 1/2 here at 60 degrees. But in this case, it's 2 pi, it's radians, so 60 degrees is pi over 3. And so it would also be here at 2 pi over 3. That's where it would be negative 1/2. It would also be, it'll be closer to the y-axis, here at 4 pi over 3. And also around here at 5 pi over 3. And so those are all the angles that have 60 degrees as a reference angle. So your answers would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And so that would be your answer just in one rotation, okay? So it'd be different if we had to go more than one rotation, alrighty? So let me know if you have any questions about how we solve this problem, but that's how you would solve it. And you could use the double angle identity anytime you have a 2x in the problem, okay? Let's look at another one. For this one, we want to solve 3 sine 3x equals 0 for x between 0 and 2 pi. So again, that's in one rotation. And this time we don't have a double angle identity. We have 3x. And so what I'm going to do is I'm going to use a u substitution. I'm going to let u equal 3x. And so this ends up looking like this. 3 sine of u equals 0. And so I want to solve for sine. So I'm going to divide both sides by 3. And so I get sine of u is equal to 0 because 0 divided by 3 is 0. And so now I want to think about all of the places where the sign is 0. Oh, and one thing before I do that, because u is equal to 3x, I need to figure out what interval would 3x be in. So if it was just x, that would be within one rotation. But if I multiply all of those by 3, so 3 times 0, 3 times x, and 3 times 2 pi. 3 times 0 is 0. That will give me 3x in the middle. And that will give me 6 pi. Okay. And so what that means is that I need to go around 3 rotations. Yeah, for 3x, you will go around 3 rotations. Okay. So what does that mean? So now when I'm considering, so 3x is u. So if I replace that with u, that means when I'm considering where is sine of u 0, I would have to do that 3 times around the unit circle. Okay, so if I sketch my unit circle over here, just a quick sketch of it, sine is 0 here, but sine is also 0 here. Okay, so every time I hit here, at those 2 points in those 3 rotations, that's where sine of u will be 0. So those points will be, first of all, 0. Because it can equal 0 if you see up here with the line underneath. And then, or over here, 0. It can equal 0, but it can't equal 6 pi. So when we get to 6 pi, we'll stop. So the first time, it'll be 0. Then when I get here, it'll be pi. Then when I come back around to this one, so from here to here, that'll be 2 pi. Then that'll be 3 pi, then 4 pi, then 5 pi. And then 6 pi, but again, it can't equal 6 pi because there's no line underneath here. So it'll be 3 pi, 4 pi, and 4 pi, and 5 pi. So that's what u is equal. But remember, we let u equal 3x. So that means now I have to take 3x and set it equal to each of those. Because u is equal to each of those. U is equal to 0, u is equal to pi, u is equal to 2 pi. U is equal to 3 pi. U is equal to 4 pi. And u is equal to 5 pi. And so instead of writing u, which I almost did here, I wrote 3x for each of those. So now I need to solve each of those for x. So that just basically means divide by 3 on both sides. So here we would get x is equal to 0. Divide by 3 here. We would get x is equal to pi over 3. Divide by 3 here. We would get x is equal to 2 pi over 3. If you divide by 3 here, you will get x is equal to pi. Divide by 3 here. X is equal to 4 pi over 3. 3. And then divide by 3 here. You will get x is equal to 5 pi over 3. And so those will be all of your solutions. You have 1, 2, 3, 4, 5, 6 solutions. 0 pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. And I'm just going to put those in braces. Or you can write x equal all of those either way. But that would be all of your solutions that will satisfy this equation, okay? So if you have any questions about anything I did here, I let u equal to 3x. Then I solved that equation with u in it. I had to adjust my rotations considering what u equal. Then I found all of the points where that statement is true. That gives me sine of that value u. And then I went and plugged in 3x back for u. So I set each of these equal to 3x and solved for x. And that gave me my solutions, okay? One more problem. One more. Our last problem. Solve cosine of 2x equal cosine x over 0 to 2 pi. Okay. Again, this is kind of similar to the first one because it has a 2x in it. And because it has a 2x in it, you want to use the double angle identity. And because there are 3 double angle identities, one with only cosine, 2 with both sine and cosine, we want to use the one with only the cosine in it. So remember, cosine of 2x is equal to 2 cosine squared x minus 1. And so we replace cosine of 2x with that. So we replace the cosine of 2x with 2 cosine squared x minus 1. And so now we end up with an equation that's quadratic in form. So now we need to move. We get 0 on one side whenever you want to solve a quadratic equation. So we'll move cosine of x to the other side. And you cannot combine cosine of x with this 2 cosine squared x because one has a variable and one doesn't. So that'll be 2 cosine squared x minus cosine of x minus 1 equals 0. And so you have a quadratic equation. The easiest way to solve it is to let u equal, this is called u substitution, let u equal cosine of x so that you can see the quadratic, and that will become 2u squared minus u minus 1 equal 0. And so you would want to factor this because there is a number in front. So you could use a quadratic formula as well, but I'm going to factor this. Because there's a number in front, I have to do the AC method. So 2 times -1, which is -2. So I want to take factors of -2 that add to the middle number here, -1. So those factors would be -2 and 1. -2 times 1 is -2. -2 plus 1 is positive. Yeah, -2 plus 1 is -1. And so then if I use the AC method, I will replace this middle term with -2u plus 1u minus 1. So all I did was replace this -u with -2u plus 1u. That's one way to do it. There's also a shortcut method. But this is the AC method. So then I will group these first two and group these second two. I could factor out a 2u in this first two. That gives me u minus 1. And then this is u minus 1. Both of these have a u minus 1 in them. So pull out that u minus 1. And there's an understood 1 here. So that will leave me, if I take out u minus 1 there, with 2u. If I take out u minus 1 there, with plus 1. And so that factors into u minus 1 times 2u plus 1. But then I will take each of those and set them equal to 0 and solve for u. So here I will get u is equal to 1, equal to 1. Here I will subtract 1, get 2u equal to -1, divide by 2, and you will get u equal to -1/2. All right, so now I have to go back and plug in cosine of x for u. So we had u equal to 1, so we're going to replace that u with cosine of x. So that'll be cosine of x equal 1. And then we had u equal to -1/2. So we're going to replace that u with cosine of x. And so we didn't let u equal like 3x or 4x, so we don't have to adjust the interval. So we will go around one rotation and find all the places where cosine of x is 1. So I'm going to sketch my graph over here. We know, or my unit circle over here, cosine of x is 1 here and 0. Also at 2 pi, but because there is no bracket around 2 pi, we won't include it. Cosine of x is negative in quadrants 2 and 3. And so it'll be -1/2 up here at our 60-degree reference angle, and then down here at our 60-degree reference angle. And so this is in radian measure. So that would be 2 pi over 3. And also this would be 4 pi over 3. And so those are your answers. That's how you would solve that equation. All right, if you have any questions about anything I did on this video, please put them in the comments. If you understood everything and it made sense to you, go ahead and hit that like button. And if you haven't, go ahead and show some love and subscribe to the channel. And I hope these videos have been very helpful for you. I hope they made sense. And don't hesitate to reach out anytime you have any kind of math question, okay? I thank you all for watching, and I hope to see you soon again.